Hi everyone, let's look at questions number 4a. So consider the surface of the solid G are bounded by the cone and the plane Z equals to 0. Compute the flux of water flowing through the surface. Okay, if the velocity, F is given, assume that the unit normal vector is oriented outward. Okay, so questions 1 is about finding the flux of water passing through the surface. Okay, so this is the surface integrals of vector field. Okay, and the second one is to calculate the surface integrals of vector field by applying the Gauss theorem. Okay, so the F is given. So based on these two questions, 1 and 2, they are actually asking you to verify the Gauss law. Okay, because you need to use the left hand side equations to solve for question 1 and the right hand side equations to solve for the questions number 2. Okay, so let's look at the solutions. Okay, so we go to question 4a. Okay, for A1. So for A1, like I mentioned, okay, it is the surface integrals of vector field. So the equation is given, it is a cone. Okay, so the equation of the cone is this. Okay, equation of the cone. And also dimensions the plane, right? The plane Z equals to 0. Right, dimension which is plane Z equals to 0. So maybe we draw this structure first. So you have a cone. So you have a cone when the 4. So the cone shape should be something like this. Okay. Okay, so this is the cone. So this point is 4. Okay, when the x, y, they are 0, so you have a z equals to 4. Okay, so the plane Z equals to 0 will be this one, right? This part. Okay, so this is the cone. So the cone, in order to find the water coming out from the surface, okay, by using the left-hand side equation, first of all, we must confirm how many surfaces are there for this 3D graph. Okay, so you have the surface number 1. Oops. Okay, so this is surface. So surface number 1, and at the bottom you have a surface number 2. Surface 2 and surface 1. Okay, so meaning that you have to do the left hand side equations, okay, which is this one. Okay. Oops. Okay, double integral, okay, of the surface 1. Okay, surface 1. F dot n dx, okay, plus double integrals of surface number 2 f dot n ds. Okay, you have to do the two parts in order to find the total flux of water. Okay, so you have two surfaces. Right, clear? Okay, so F, okay, is not the questions. F. Now is the n you need to find. Okay, you need to I. So we look at the n for the surface 1. Okay, surface 1. Okay, so the n mentioned by the question is outward, right? Oriented outward. So you will use equation negative fx, negative fy, 1. Okay, and the bottom will be fx squared plus fy squared plus 1. Okay. Alright. So now what is your f? Okay, so you are referring to this surface. So of course you will take the equations of cone, okay, which is equals to 4 minus x squared plus y squared. Okay, so your fx will be equals to, okay, so this is 0, nothing to do. Alright, quite similar to the previous one. So 4 will become 0, so you will have a negative. Okay, negative 1 over 2, right? X squared plus y squared, negative 1 over 2 and 2x. Okay, you can cancel it. So you will get x over x squared plus y squared square root. Alright, and negative. So for the fy are very similar. Okay, so you will get this thing, x squared plus y squared and square root. Okay, so the n will be, okay, so the n will be negative x over square root x squared plus y squared. Okay, and then negative y square root x squared plus y squared, right, and 1. Oh, just now we have a negative here, right? Okay, and this is also negative. Okay, so it should be positive here. Okay, right. Okay, I think we'll focus on this part first. Okay, focus on this part first, then later on we go to the next surface. Right, so let's perform the double integrals of vector fields. Okay, for the surface integral. Okay, so surface integral. Okay, the f given is x, y, and 2, right? So it dot product with this. Oh yeah, I forget this, the bottom part of the n. Right. Let me continue back the bottom part. Okay, so this one I'm going to delete it. Oh, I don't need to delete, maybe I can move down a bit. Okay. Over. Okay. Alright. Okay. Continue. So this one will be x over x squared plus y squared, right? So we have y square root x squared plus y squared and 1 and dA. Okay, so this one I straight away replace with the dA. Initially, the equation is the dx over here, but I explained before, you can cancel, okay, the bottom part, so it become dA. Right, so let's continue. Okay, so it will become x squared over x squared plus y squared, right, and plus the y squared over x squared plus y squared and plus 2, okay, dA. So dA stands for the area. Okay, area for the surface 1. Okay, so this one you must refer to the projections. Okay, so if you refer to the projections, you will see the circles like this. Okay, it's a circle. Okay, it's a circle. So I will use the r, dr, d theta. Okay, and this also means that you have to convert it. Convert the x and y to the r. So you can convert it. So this one when you add together, so you will get r squared over r, right? Okay, and plus 2, and you have outside r, dr, d theta. Okay, so now very important thing is we have to define the interval for the r and also the theta. Okay, like I mentioned just now, you will see a circle. Okay, so the theta for the circle is definitely from 0 to 2 pi. So if you want to know what is the r, so you have to start from the equations of the cone, okay, which is y squared. Alright, so when you put that z equals to 0, okay, so this will give you the radius of the circle, which is 2, okay, which is 2. So the dr will be from 0 to 2. This is 0 to 2 pi, right? Oh, no, it's not 2, it's 4. I made a mistake. So better don't skip the steps. Right, 4 equals to x squared plus y squared, square root, right? Okay, so it will become 4 squared. Okay, so the radius is actually 4, it's not 2, okay? So don't skip the step, 4. Okay, so you can start to solve this thing. Okay, so this one you can simplify it. So make it to become r squared, right, plus 2r dr d theta. So for this thing, you can press calculator, integrate r squared plus 2r, 4 and 0. Okay, 0, 2 pi. This part you have 112 over 3. And if you multiply 2 pi, you get 224 over 3 pi. Okay, so this is the flux of water coming out from the surface 1 of the cone. Okay, so now we have to go to the second part, not yet finished, the second part, okay, which is the water coming out from the surface number 2. Okay, for the surface number 2. So okay, so the information we have for surface number 2 is, okay, it is a plane located at the position z equals to 0. Okay, z equals to 0. So when the z equals to 0, when you want to do these calculations, right? Okay, negative fx, okay, negative fy 1. Okay, so this is the calculations, right? For the flux, you need normal vectors. Okay, so the f over here will be equal to z, okay, and in this case the z is 0, and which means the fx is 0, fy is also 0. Okay, so you will cancel this thing, and you left the 1 here. Okay, so when you do the double integral again, okay, so the f is equals to, okay, x, y, and 2, right? So now we left this 1, so it will become 0, 0, 1, okay, dA. Okay, so the dA over here is the same as the dA in the surface number 1 because it is still the same circle. So we put 0 to 4, 0 to 2 pi, right? Okay, so you will have a 0, 2 pi, 0, 4, then 2 dr. No, you have a r, dr d theta. Okay, so let's calculate this thing. So you integrate the 2r. So this one you get 16 d theta. Alright, Okay, let me check just now what is the flux. The flux is outward, outward. Okay, meaning that you don't use this one. You don't use this one. Okay, you use these equations, another equations for the outward. Okay, but it's downward. The flux coming out from the second surface will be downward. Okay, like this. Okay, the flux. So I choose the other equations. Okay, if I choose the other equation, this one will be negative. You will have a negative, and 32 pi. Okay, so the total flux of water coming out from the cone will be equals to, just now we have 224 over 3 pi, and then you minus the 32 pi. Okay, they are in different directions. Okay, so it will be equals to 128 over 3 pi. Okay, so this is the question number 1. You solve the left hand side of the divergence theorem. Okay, we'll go to the question number B. Okay, question number B. Oops. We go back a bit again. Okay, calculate by using the Gauss theorem. By using the Gauss theorem. Okay, so it is the same force. Okay, so we go to the Gauss theorem. Okay, what is Gauss theorem? Okay, Gauss theorem is telling us that, okay, if this is the surface integral of the vector field, okay, it will be equivalent to the Gauss theorem, okay, where the divergence of F is here and the dV is here. Okay, so just now in the question A, we have complete the left hand side, okay, because it has a two surface 1 and surface 2, we add them together. Now in this question B, we need to solve by using the Gauss theorem at the right hand side. Okay, so for this one, okay, you can see is the divergence of the vector F. So the first thing that you have to do is to find a divergence. Okay, so let's find the divergence. So divergence means that your dot product, okay, this one. So this is the del. Your dot product with the F, which is the X, Y, and 2. Okay, and dV. dV, yeah. Okay, so let's simplify. So you have 1 plus 1. 1 plus 1 plus 0, Okay, so the dV over here, you have to refer to the 3D graph, which is a cone. So normally the cone for dV, we will use the cylindrical coordinate systems. So meaning that we use the dz, r, dr, d theta. Okay, right, so this is 2. Okay, now we have to define the interval. Okay, interval for the z. Interval for the z, you have to look at your 3D graph again. Okay, so imagine you are sitting inside. Okay, you want to define the dz. When you refer down, okay, you see this horizontal plane at the position z equals to 0. Okay, so when you refer up, you actually see all these surface. Okay, so the cone surface. So the cone surface is represented by the equation of the cone. Okay, so your dz, okay, will be from 0. Okay, so this is the base, and then you go to the equation of the cone. Equation of the cone, which is 4 minus x squared plus y squared and square root. Okay, r is based on the projections. Okay, maybe I will draw here. Very simple one. So this is your cone, right? This is your cone just now. So you pick the projections. Okay, you will see this circle. Okay, this circle. Just now we already know what is the radius, right? Okay, so the radius is 4. Okay, so it will be 0 to 4, 0 to 2 pi for a circle. So this will be 2 dz r dr d theta. Okay, so this part we could convert it into the r. 4 minus r. Okay, it will be 4 minus r. Okay, so we can do this now. So it will be 2 4 minus r, right? Then you have r, dr, and d theta. Now we integrate it. 4 minus x. So now is 64 over 3. 2, yes, you see 128 over 3 pi. Okay, so this is the answer that we can find by using the Gauss theorem. Okay, it is much more simple. You see, just a few steps, you can get the final answer. Whereas if you use the equation at the left hand side, you have to find for the surface 1 and also the surface 2. Okay, you can see that their answers are the same. Okay, so this is the questions number 3a. And so it's number 4.